Hello and welcome all. Now we shall see YouTube heat exchanger. So a YouTube 1-2 heat exchanger, it consists of U-shaped tubes. So this is the difference. Why this is named as YouTube heat exchanger? As in this case or in this heat exchanger, the tubes are in the form of U shape. Okay, the tubes are in the form of U shape, both the ends of which are fixed to a single stationary tube sheet. Okay, so this is a U tube, you can see this is a U tube. So as many U tubes are there, for our convenience we have shown here just one U tube. Okay, there may be many as such U tubes that build this YouTube heat exchanger. Okay, so for our convenience we have shown here just one in a heat exchanger. So this U tube is fixed, okay, fixed to a stationary end. Okay, this end is called as a stationary end. It is fixed to a stationary end. So why it is called as stationary end? Since this tube sheet, okay, this tube sheet is clamped in between. Okay, it is clamped in between shell and channel. Okay, it is clamped, this tube sheet is clamped in between shell and channel. Okay, so there is a flange support over here, and this flange support would clamp this tube sheet in between shell and channel. Okay, so this channel is having two openings, one for the inlet of fluid and other for the outlet of fluid. Okay, so here you can see this is a channel which is having two openings, one for the inlet and other for the outlet. Okay, so this is a one end of this YouTube heat exchanger, in which this stationary, or we can say that this tube sheet is called as a stationary tube sheet, since it is clamped in between shell and channel. Okay, while the other end or the opposite end of this heat exchanger is covered with shell. Okay, it is covered with shell, and it is actually a integral part of a shell. It means that there is no as such channel is there on the opposite side, on the opposite side of this YouTube heat exchanger. Instead of that, this channel shell, there is a shell cover. Okay, this shell cover is integrated with the shell itself. Okay, shell itself. So we can say that it is a shell cover which is an integral part. Okay, it is an integral part of the shell. Okay, it is an integral part of the shell. This shell is provided with two opening, one for the entry of fluid and other for the exit of the fluid. Okay, so this arrangement is done. Okay, this arrangement is done to go for what we have seen, that in a fixed tube heat exchanger, the problem of mechanical cleaning of the tube from the outside was persistent. But here in this case, this problem is resolved, that this tube bundle from the channel side, okay, this tube bundles from the channel side, or this U tube from the channel side, can easily be separated, and mechanical cleaning from outside can be done. Moreover, as this tube sheet is not fixed to shell. Okay, this tube sheet is not fixed to shell. Okay, as we have seen in fixed tube heat exchanger, and therefore this YouTube heat exchanger would not show any kind of or any differential thermal expansion between the shell and the tubes. Okay, shell and the tube, since it is not welded. Okay, this is not welded. Instead of that, this is having a flange support. Okay, this is having a flange support. Okay, and we can say that whenever there is a flange support or it is clamped, that is the tube sheet, when it is clamped in between shell and channel, then differential thermal expansion that occurs between shell and tube is actually absorbed, or it is absorbed by the U bends. Okay, U bends that these tubes have. Okay, U bends that these tubes have. Moreover, this is again a reason that the most of the what we say thermal expansion, differential thermal expansion, is being absorbed when they are clamped. Okay, tube sheet is clamped. So welding actually causes the welding of shell and tubes or tube sheet causes the differential thermal expansion. That problem also has been resolved in the U-tube heat exchanger. Okay, each U-tube can expand or contract without affecting the other tubes. Okay, this U-tube, that means one such U-tube is shown over here. So there may be many such U-tubes that make this U-tube heat exchanger. Okay, therefore we can say that each U-tube expands or contract freely. Okay, this each U-tube can expand or contract freely. It can it do not, or it won't affect the other tubes. Okay, it do not affect the other tubes. That is why this U-tube heat exchanger is very helpful, that mechanical cleaning of this U-tube can easily be done, as well as it absorbs the differential thermal expansion between shell and tubes. Eventually, this also have some disadvantages. These disadvantages run as this arrangement is different as compared to the arrangement of heat exchanger that we have seen. So tube bundles were there, straight tube bundles were there, which may be parallel to one another, but here in this case the tube bundle is U-shaped. Okay, U-shaped. So number of tubes or U-tubes, okay, that can be fixed to the tube sheet becomes less, as the openings, okay, the number of openings or holes in the tube sheet of a given diameter, okay, this may be affected. Okay, this may be affected, and there is a possibility that this U-tubes, okay, these U-tubes may get loose. Okay, they may get loose when the hole size of the tube sheet, okay, tube sheet extends or contracts, okay, during the process. Okay, so this may be one of the limitation, or we can say that is a disadvantage of U-tube sheet heat exchanger. The bending tubes of a very short radius, the number of tubes holes in the tube sheet of a given diameter with this exchanger are less and than that of the fixed tube heat exchanger. That is this bending, okay, bending of the tubes, okay, bending of the tubes of very short radius, okay, as well as the fixing of this U-tube onto the tube sheet. The holes of the tube sheet, holes on the tube sheet may get affected during the process, and there is a possibility that this U-tube can lose during the process. So such problems or such limitations can be of this U-tube heat exchanger.